This is a production of Cornell University.
Welcome everybody to season 3 of the Cornell Turf Show. This thing started back in 2020 as really an outlet for Frank and I to talk into the void, to feel like we were talking to somebody. But we've gotten such great feedback from our live audience, the people that watch it on YouTube or listen to it as a podcast. So we're really excited to bring back season 3. Every year we're trying to get better, and our theme is the fastest 30 minutes in turf. We want to get you guys in here, get you a bunch of information to you, timely information on a compact time frame, and get you out of here quickly. So thank you guys for sticking with us. For anybody new listening, my name is Carl Scamenti. I'm an urban environmental scientist here at Cornell, and joining me, my co-host is Dr. Frank Rossi, associate professor in the plant science department here. He's director of agriculture science major now, and he's our turfgrass extension specialist for the state of New York. So happy to be with you. Thanks for coming back for third season. Our Thursday shows are going to be kind of golf focused, and our Friday shows will flip flop between lawn and landscape and sports turf. So we'll have a couple segments for you every show, and I'll start us off here like I did last year with on our golf show, a BMP.
Hold on a second, Carl. You're going too fast, brother. You're going too fast. We're getting started. We're working out the kinks, you and me. And so, Carl, let me just do it. And I'm going to bring you back because I'm going to embarrass you in front of everybody. And the good thing about this that we've noticed is we're always happy to have folks here and have a conversation. And Carl's right. I think we needed an outlet to speak into the void, and also that, you feel like you want to do something. I think you get into this line of work as a matter of service. So for those of you listening on the podcast or watching it as a recording, it also works at 1.25 and 1.5 speed, and then 30 minutes does go faster, Carl. So with that, let me thank the Met Superintendents Association and the Long Island Golf Course Superintendents Association for not only the longtime support of our turfgrass program, but also the support of this particular madness that Carl and I are in on. So as Carl said, you remember when this thing started out, it was, let's just help each other a little bit. Things are bad for everybody. How do we make it okay? And I want to give you some numbers. As a good scientist, I went and did some calculating on these things. We're starting our third season. We've done 54 shows to this point. It's at about a half an hour each. It's 27 hours of education. Of course, because we go faster than 30 minutes, it's likely actually less. We've had 43 guests from 17 states. Carl and I have been completely nuts talking to people from all over the country. And thank you all very much for 11,000 views. Now, that's not as much as the turf nut gets to spread pigment and sand on his lawn, but we're going to be happy for it anyway. Let me get to my next slide. Okay. So, I always used to like to put a picture of something to make us smile. This happened to me last week. This made me smile. These are my former graduate student colleagues at the University of Rhode Island. This is Randy Van Yares here on the right, runs the Catholic cemeteries in New York City. And of course, many of you probably know Professor Scott Ebden at Stockbridge. I was a graduate student for Dick Scogli after Scott, and Scott was there after Randy. So this was a nice little thing that happened in Rhode Island. And honestly, it felt really good to get back together in groups of people. And as long as the CDC says this is okay, I, for one, I kept saying, I'm so happy to see people. I'm even happy to see people I don't like. So with that, I'm going to introduce my colleague here who didn't give himself enough credit for his new position in our program as the urban environmental specialist, coming from a long time period of coordinating our state park golf course project. Carl, last golf season, won the New York State Mid-Am. So this was a big deal, of course, right? And I'm going to embarrass him and tell him also he's been my colleague on this really important project that I will run the slides, Carl, and you run us through the BMP tip of the day.
Yeah, so this project, Frank, you're talking about our friends at the New York State Pollution Prevention Institute up at the RIT, Rochester Institute of Technology. We partnered with them and really trying to get golf courses to adopt BMPs. And it's been a 3-step process. We're in our 3rd year of this now. The first year was about measuring that adoption. So randomly surveying a bunch of golf courses in our region getting data. And then based on that data, step 2 is outreach and education. And so we did this last year on our turf shows, a BMP tip of the day. So we're still in this step 2 outreach and education period. And we're using this infographic poster that we've created. So a really kind of smooth, streamlined way of looking at BMPs, par, birdie, eagle, right? Pars are things we think everybody should be doing. Birdies and eagles, kind of that next level. So one of the pars is in our water section, managing water, is looking for leaks. And I know we haven't turned on our irrigation systems yet this year, and the leaks are coming out of the ground, right? It's leaking everywhere. It's sloppy, and we're getting the snow melted off. But soon enough, you're going to be starting the irrigation systems up, and just getting out there and looking at the heads run around is really informative. So I got a chance to do this at a couple golf courses last year. Now we did an irrigation audit where we get this really cool data. And what I'll say is when you see a head that is obviously throwing incorrectly, whether it's throwing too low or it's not rotating the same speed as the other heads, it shows in the data. So this is an example of just us kind of putting this data together on a certain green. And you can see that head A up there in the top left, applying almost 2 times the amount of water as other areas of the green. And that head was throwing a little bit low. I wouldn't say I would have said, oh yeah, it's 2 times as much water low, but I think that's the cool thing about matching the data to what you observe. And in this case, head C and D, those 2 front heads, just the topography of the green was what is throwing off the uniformity there. So those heads were working fine. Just say, hey, run those heads a little bit longer, but looking for leaks. When you see something wrong with the head, I can guarantee you it's going to show up in your uniformity, and that extends throughout the season. So I know we're not watering yet. You guys probably don't want to see water for another 3 months, but let's get it in your head. Just take a trip around when you first start up that irrigation system and prioritize this stuff early.
And Carl, I'll just add, that was great. And I'll just add, this is enormously insightful to get data, right? Consistent with our theme about data-driven management, right? And this is a really good indication. But one of the things you mentioned, we just want to reinforce, and you'll probably come back to it, is we got a ways till we got to water because the sun's not that very high in the sky, right? If you look at the sun governing the amount of water we're going to use, we're a little ways. You can feel it warming a little bit and it gets the juices going, but we're a long way from even drying out, never mind the ET levels. So thanks a lot, Carl. And let me, since we are talking about drying out and weather, I had the pleasure of being in Rhode Island last week for the New England Regional Turf Foundation show. As you saw, it was sort of old home week for me. I hear all people with more screwed up accents than I got, which always makes me happy. I lived in Rhode Island for 4 years, so I know what a screwed up accent sounds like to all my Rhode Island brothers and sisters that might listen to this. And one of the things I did, Michelle DaCosta, Professor Michelle DaCosta from the University of Massachusetts, led a roundtable discussion around winter injury. And I'll talk a little bit about the Minnesota project that everybody's collaborating on across the northern areas as I get into this. But and it was really just a listening session, which many of you know from me, not the easiest thing to do, but I actually did it pretty well. Stayed quiet, Jeff Carlson told me, for almost 15 minutes before I said something. And what I heard the superintendent say was this was a roller coaster year. And of course, this is the greatest roller coaster in the history of the world, the cyclone at Coney Island in Brooklyn. So let's look at what that roller coaster temperature looked like. The thing you got to keep in mind, and this starts to get cumulative now, right? The earth is warming significantly, and we're starting to really feel the impacts of that. And in really short, and in a really, way to think about it is warm air holds more water. Warm air holds more water. So as we warm, there's just going to be more water coming up and around. Now, that doesn't mean you're not going to have dry spells. So let's start with temperatures. The September, November period, the fall period, the record warmest for minimum temperatures and almost the record warmest for the ever period we recorded in these 3 months. Then you look at December and you see the same trend continuing in the Northeast and of course, really bad in the Texas central part of the country. Now then January comes, so we're up and now we're down, right? Now we're down and you can see January started to rank quite a bit below normal. You're in the top 25% coldest Januaries we've ever had. February, now you start to see the effect that just one cold month, right, is not going to really have that much of an impact. And now we're starting to see already record warm temperatures, but not so much the minimums, but now the maximums are coming up a little bit. Typically, we associate the warming world with a increase in the minimum temperatures, not necessarily that it's going to get particularly hotter, although it is getting particularly hotter in places like India and Death Valley, where they're starting to record temperatures in the 140 range, which becomes uninhabitable for human beings, right? So here we are. It's February, nice and warm. We're only a couple of weeks into March, and it's sloppy, right? So what does it look like moving forward? Temperature-wise, the NOAA outlook indicates near normal, and you look at our more refined Northeast Climate Center predictions, and we're in a longer period, we're saying we're likely to be above normal temperature. So looks like we're going to be warming a little bit, right? The degree day forecast seems to indicate at base 50 that we're going to get about 10 to 15 everywhere north of Long Island, right? Once you get south of Long Island, and except for the higher altitudes, you get down into the Delmarva region, you're starting to get, 40 to 50 growing degree days. So you're going to see a big acceleration in the growing season the further south you are. And you can really see that demarcation where the cold temperature still dipping down from the north, right? The trough in the jet stream is bringing that cold air down. And we're going to stay a little bit on the cooler side, even though the forecast says overall we're going to be warmer. The 2-inch soil temperatures, and I was glad to see this because I looked at this a couple of days ago, and we're having some problems with our forecast modeling page. So hopefully you'll check back. In the meantime, do what I did, go to GDD tracker, and we'll talk about that a little bit later. But a lot of these maps are working pretty good. The seed head map, not so good. I was noticing just a couple of days ago, the temperature in the middle of Long Island, where I chat with people routinely, was look on this map like it was still in the upper 30s. And I shot a note down to Andy and Mike at that very famous golf course on Long Island. And they said, oh, we got 52 degrees. So as of yesterday, it seems to be resonating that you're starting to see, you're getting into the 50-degree range. Now, this is starting to feel like an early spring, because the thing that I always like to keep in mind is, at a 2-inch depth, the soil does a lot of buffering of air temperature, right? Once it gets warm, right? If it keeps getting wet, it'll probably stay on the cool side. But once it gets warm, it starts to get warm, the sun keeps coming up. That's where you're really going to see an acceleration to the growing season. Now, let's get back to the weather over the winter and talk about moisture, because this is a perfect lead in to the discussion of winter problems moving forward. So here we are, October to December on the left, right? For those of you watching on the podcast, or obviously listening on the podcast, you look at central New York from Syracuse over to Rochester, you've got this enormously wet period, but pretty much normal, even dry around the New York metropolitan area, right? Now you see in the December to February period, it's starting to get a little drier across the board, at least as it looks here. Now, when you look at how this is shaken out, I was a little bit surprised to see this because it has felt a little bit wetter. Well, look where I live. Where I live, it's right in the center of the biggest wet spot. I'm confident there's an atmospheric river over where we live. But when you get into central Pennsylvania, Harrisburg, into the Hudson Valley, Orange County, into the Connecticut River Valley, and especially to the 5 people that live in northern Vermont, right? It's going to be really dry. It's been really dry the further north you get. Now, the Burlington area looks like it's done pretty well, but a lot of the Adirondack Park has been a bit on the dry side, right? Long Island is really split down the middle. You get closer to the city and it's indicating it's on the dry side. And the further out you get, this period looks like it's been a little bit on the wet side. So again, moisture tends to be very site specific with the way we're able to take this data, and climate change is doing it. So what about just the week we just came from? Well, most people got a little bit of rain, but along the coast got a little bit more, a little bit over an inch, particularly on the east end of Long Island, out into the Cape, Rhode Island. The bunch of rain fell out there over the last 6 days. And you can see now, when you look at precip minus evapotranspiration, most of the Northeast right now is in an excess, right? And you know, you look along the coast of Jersey where Atlantic City is, Delaware, the Delmarva area, especially along the coast, some very wet conditions and actually pretty dry. Not pretty dry, but just a little bit drier as you get north. But overall, plenty of moisture in the system. And the outlook is favorable for more moisture, right? So this is not what everybody wants to hear, particularly if you're trying to get some work done. Okay, moisture. What happens to it when it's cold? Now, we're on the outside of this now, so a lot of this could be retrospective. But again, that roundtable discussion that Michelle led, Professor DaCosta led the other day was really insightful. And so we're going to take a couple of minutes here where you normally have a guest, and I'm going to draw on things I've been thinking about for 30 years and talk about winter injury here. So the first thing is, you know, you got to keep in mind with winter injury is if you have moisture that creates a layer of ice. Now, there's different kinds of ice, but the simplest way to think about this and what everybody sweats is you got a lot of ice and it sits on there for more than 25 to 30 days. Something's going to happen. This is the big what's going to happen. Well, here's what I promise you. If it's there for 60 days, the PO is going to be dead. If it's and you're probably going to see a 30% reduction in bentgrass as well, depending on the variety. Dave Minard did this work many years ago at Iowa State, making thick sheets of ice in the middle of Iowa in the 90s. So a lot of old work tells us essentially you're suffocating the grass. And if you can get cracks in the ice, you can help it. Now, here's the dilemma. This came up in the roundtable. Should I go out and aerify? Should I take the snow off? Should I take the moisture off? Right? Look at this picture. Here's a person going out with a shovel, taking it off. I mean, how much damage do you do doing this? Now, I saw somebody on Twitter the other day, I should have thrown it in here, spreading black sand with a snowmobile, right? Driving across back and forth the green with snow and ice on it, throwing dark material, because as the sun comes up, if it cracks and gets you a little bit of air in there, you're solving some of your problem. If ice encasement and anoxia, right, lack of oxygen is your problem. Now, what's more likely happening is what they're studying in Minnesota. They're studying in Minnesota where what's happening over the course of the winter and when does grass die? Does it die in December, January, February? And what are the environmental conditions under these winter blankets, ice, open, whatever it is? And they've developed a monitoring system. And here's a picture of Gary Dieter's work at the University of Minnesota research plots on the right, where he's actually holding ice and making ice on top of the ground. And you'll see these poles in a lot of these slides. That's all part of the people cooperating across the northern part of the North America. You can see they've got people well up into British Columbia, up into Edmonton and Alberta, the Alberta province. It's, you know, and obviously a lot of people in the central Midwest. And also we've got a bunch of folks throughout New York State and New England. So obviously a wide reaching project, big kudos to the Minnesota folks for pulling this together, and everybody else for stepping up, and the golf superintendents for stepping up. So here's a picture from Kevin Frank, one of the cooperators in Michigan State, literally 24 hours apart, So this actually is the thing most people have to worry about, because these, what we call in technical terms, incipient freeze-thaw periods, right? These freeze-thaw periods where it goes up and down, right? You get these pools, right, where water freezes and thaws. When open water is hit by direct sunlight, it has a greater capacity once it's heated to hold on to that heat, right? Now, in some ways, you'll notice this in grassway ditches along the side of the road. A lot of times, they're the first thing to green up. You're like, how the hell can that be? You'll also see this in compacted soils. How the hell can that be? Because those bodies are able to get the sunlight, get the heat, and hold it, right? So they hold it, which means they transfer it into the ground, then into the grass. And guess what happens? The grass breaks dormancy. So this is the rub. So you can go like this, and you can wake up and you see where the water was, and you got dead grass. So these freeze-thaw periods, the best way to think about this was some work done back in the 90s by Jim Ross and the group out at the Prairie Turfgrass Research Center, right? They had annual bluegrass biotypes, everything. There's no one person's annual bluegrass is like another, right? So they had 4 biotypes. One of them was the perennial type from the Minnesota breeding program back in the day. I think they call it True Putt nowadays. So here you got 4 biotypes. And these plants were completely hardened off before they were exposed to these temperatures. Okay. So they were perfectly hardened off until they got 39 degrees Fahrenheit for 24 hours, or 39 degrees Fahrenheit for 48 hours, or 46 degrees Fahrenheit for 24 hours, or 46 degrees Fahrenheit for 48 hours. And for those of you watching here on News Channel 8, you can see that it takes about 48 hours at 46 degrees Fahrenheit to significantly lose your low temperature hardiness, right? I mean, yeah, it's got to get down to 1 degree, 3 degree, but there's one biotype, if it gets to 17 degrees, it'll kill it, right? It'll kill 50% of the population. So it's the breaking of dormancy that's leading to the problems that's ultimately causing the damage. Now, so where does this happen? So here's a grass plant. Again, if you're listening on the podcast, I got a grass plant here, and now I'm pointing at the crown, the base of the plant. At the base of the plant, there are crown cells. Those cells either differentiate themselves into leaves or differentiate themselves into roots. And typically what happens is the root cells die, right? So the root cells get killed in an annual bluegrass plant, which means when the water's there, it starts to green up and produce leaves. But as soon as it dries out a little bit, the lack of any rooting leads to the death of the plant, right? So what you're doing is seeing now what happens at the cellular level. So we're doing a deep dive here. How does this happen? Cells have water, right? They use water to grow. When they're hardened off and acclimated to winter, they reduce the amount of water in that cell because they're not growing. They don't need the water pressure to push the cell to grow. So they inherently have less water that's available for freezing. But what does happen is water starts to freeze in between the cells, usually around bacteria, usually around some kind of microorganism that lives inside the plant, starts to crystallize and then draws water out of the cells. This is what's known as crown hydration damage. When you hear people say crown hydration, that's what they're talking about. Now, ultimately, you see there are some differences. Obviously, in this picture, you see the annual bluegrass, predominantly annual bluegrass fairway, completely dead. You see the bluegrass rough on the right, completely alive. And now you know how much bent grass you have on your putting green because all the annual bluegrass is dead. We have occasionally seen big differences in mowing heights. Typically, you see more damage on lower than higher. But in my opinion, species makes a much bigger difference than mowing height. Covers. This is a strategy used at a lot of places, impermeable covers. How does this work? The beauty of this technique is it keeps the water out. And to keep the water out, look what you got to do. You got to dig those sides of the cover in so that the water can't get underneath and get trapped under there, because then you're screwed. Now, there's many different kinds of covers, right? Impermeable covers with like a foam insulation that separates the cover, creates a little air layer, or like bubble wrap, that like a pool cover. Now, both of these things are trying to simulate fluffy snow that provide that air insulation underneath the cover where no moisture is getting in. So courses that have adopted this strategy and have figured out when to put them on, how to do it, when to take them off, because ultimately you got to get them off. You take them off, they're really green, you get 10 degrees, the grass looks even worse than when it was when you started. So this is not just, oh, let me try these covers. It's let me get a system to see if this takes some of the crapshoot out of trying to get these plants through the wintertime. All right, Carl, as I wrap up, and maybe you got a couple of questions for me, I'll just remind a lot of guys are thinking about seed head stuff. The GDD tracker is saying, whoa, man, we're close. Here's on the left, you see Proxy Primo. We're in the target zone. Looks like we're going to be for a week. Embark, for those of you still holding on to some Embark, you still got a little bit of time. And, I'll just remind you, again, if you're looking at this, you can see the difference between treated and untreated. Oftentimes, you still have seed heads in treated conditions, but when you don't have seed heads, suppression, it looks pretty bad and looks pretty bad for a long time. Now, the cornerstone of seed head suppression these days now has moved to a fall application. And here's some data from Sean Askew showing that winter spring application look at the amount of seed head suppression from Proxy. You also get quite a good seed head suppression adding the winter only. You can also see Embark works pretty good in the spring, better than Proxy. If you still got some, I'm a big fan of Embark. And again, at the end of the day, the Proxy fall and spring application, you're getting 90% suppression with a spring app. So don't worry about timing, go crazy, because you're already locked in for some pretty good suppression with just a fall app. Now, I'll leave you with this point because maybe some of you are itching to get your crabgrass control out there. And all I'll tell you is what my pal Randy, got to have dinner with him up in Rhode Island. Early on, early gone is his favorite line. The sooner you put this crabgrass material on, the more likely you're probably going to have to come back and retreat because the crabgrass pressure is moving well into July and August. Okay, Carl, how we doing?
We're doing great. That was a great review of really winter damage, Frank. And I hear you categorizing these as two things. We talked about this the other day. Physical ice forming on the green and suffocating the grass. That's one. But what I hear you saying is the bigger risk of injury is that the roller coaster sort of weather that we get, freeze thaw, that's the biggest risk of injury. Ice forming in literally the plant with this crown hydration. So I don't like that I heard you say that this is a roller coaster year between last fall being kind of warm. Did the plants harden off very well? This spring kind of having this heavy precipitation. Okay, we're going to get warm. Maybe we'll get another freeze. So I'm thinking about, okay, people are going to start having to find management solutions for this freeze thaw cycle. How do I keep water off of the green so that it doesn't kind of get into the crown? You mentioned covers as an option. Surface drainage, I think, is something we got to mention, right? And have you seen strategies of people? I've seen kind of a trough where they sod cut something through the green as a channel to remove water. Yeah. What do you think about trying to promote surface drainage as a way to prevent this?
It's everything. Honestly, you look at especially the old golf courses that didn't really rely on any, internal drainage because there wasn't such things at the time. They always relied on surface drainage. So, and all these things you've mentioned, over time, things change. And I'll also say, a lot of times the biggest issues are these bird baths. You just get these little areas where it's just a slight depression. And I've seen people go to the extent of drilling and boring a hole and old push-up POA greens, boring a hole down literally 3-4 feet and leaving it open for the winter. So you're exactly right, Carl. Some strategy of minimizing persistent moisture that is then available to either freeze and stay frozen or warm and then freeze is really the way to. I've always felt like it's the only really thing you can try to do. But I'll say this: go out further west. Bill's talking about desiccation. So right. You may have a high green that doesn't get snow cover, that doesn't get this, that doesn't get that. And then you got the other problem, which is all the water gets sucked out. Yeah. Right. Bill's found you can't really maintain soil moisture in some uncovered conditions. So I don't want to leave people with the thing that this is the only way grass dies in the winter. These are the things we're worried about currently in the Northeast right now. I got to tell you, it didn't look like a bad snow mold year. We're going to come back and maybe have a snow mold guest or some discussion about what's going on with snow mold in a couple of future shows. But Carl, any other questions? Because, 30 minutes.
We're right at the 30-minute mark. One of our attendees said that they use covers to very, very good success. And that's certainly a way to go. It just takes you got to have the labor, right? And a lot of courses out there don't. So like you said, moisture management is key, Frank. And whether it's in, we talked about looking at your irrigation heads earlier in the show, we're talking about drainage now. That really is a key across the season. So with that, I think we'll wrap it here. Episode 1, season 3, the Cornell Turf Show in the books. We'll see you guys tomorrow. We'll have Dr. Art DiCayetano of the Northeast Regional Climate Center on. He'll give us kind of a rundown of some cool weather stats from the winter.
You'll hear from a real weather person, not me. I play a weather person on TV.
That's correct.
See you, everybody.
See you, everybody. Have a good one.
This has been a production of Cornell University, on the web at cornell.edu.